All right, for this bell work, we're gonna solve this equation. Looks like we're only gonna need two principles of equality on this one. But there is no distribution, no combining like terms that I see that is needed. So straight to principles of equality. I was gonna bring our equal sign down, but I see I got this plus 14. I don't want that with my 11x. I wanna isolate my 11x's. So I'm gonna zero out that plus 14 by subtracting 14. But it is a principle of equality, so if I just subtract 14 on the left, then I also need to subtract 14 on the right as well. So that will zero that out, allowing me to drop my 11x's, which is now isolated. That's what we want. And then I got negative 19 minus 14, which appears to be negative 33. The last thing for this one is we want the coefficient of x to be 1, so we end up with a 1x, not 11x's. So I need to change the 11 to a 1. I'll do that just by dividing it by itself. But again, it is a principle of equality, so if I do it to one side, I need to do it the other side as well. This gives me negative 33 divided by 11, which is negative 3. So the last thing I'm going to do is check, even though I'm not actually going to work this out like we've been doing in the past. I'm just going to come up here and say, well, if I replace this x with negative 3, will it actually give me a true statement? Well, 11 times negative 3 is negative 33, and then plus 14 is negative 19. So that does give us a true statement. And now that I know that if I replace the x with negative 3, I get a true statement, I know that this is my solution. Okay, so nothing we haven't seen here on this bell work. We've seen all this stuff in the past, but we'll just be expanding on it just a little bit more today. All right, looks like we got two objectives. First one, I can simplify an equation with distribution and combining like terms if needs be. Because we know sometimes we don't need distribution when solving equations or combining like terms. Like we saw in that last one, we just went straight to principles of equality. But if we need to be able, we need to be able to actually distribute and combine like terms. If not, we'll just use principles of equality, and that's our second objective there. So take a minute and copy these down, please. So what is the solution? Just like we saw in the bell work, it's a value that you replace the letter with in order to make the equation a true statement. So remember, it is possible even using an equal sign to make false statements, but we need to be making true statements. Then the distributive property, remember it's just multiplication. So if it helps you to see the multiplication between the a, whatever that number is, and the parentheses there, then do it. Okay, now if by chance we saw something like this, I would treat this distribution. So this first one would be a times b still, but the second one here I would treat as a times negative c, which generally would make that a negative term, so I would put a minus sign between. But if a were negative, I'd have a negative times a negative, which would then make that positive, and it's possible that you could end up with a plus sign between the two terms after distribution, even though it started out as a minus in the beginning. Then finally, combining like terms, we should only be seeing x terms and constants. And remember, x terms cannot be combined with constants. So we need to make sure that when we use principles of equality that we're lining up values according to what type of term they are. And yeah, all that stuff is review, just like this one is with principles of equality. Addition and subtraction principles of equality we use to make zeros. And then multiplication and division principles of equality we use to make ones. Now, we don't just do this randomly to make ones, we're actually targeting the coefficient, which just like we saw in the bell work, a coefficient is the number that's being multiplied by the letter. So yeah, when we're using the principles of equality, we'll first use addition or subtraction to make zeros, and then we will make ones with the multiplication or division principles of equality. So first, when we solve equations, if you see any distribution that's necessary, you'll do that. And then after that, you'll combine any like terms, and then principles of equality to make zeros then ones. So here's it's kind of a big, well, it kind of looks big, but it's not too bad. So the first thing I notice on this one is the parentheses here. Okay, since I see some parentheses, this means that I'm looking to do some distribution. Okay, so I'm going to take this -5 and distribute it, meaning multiply. Maybe multiplying that -5 by first the 1x, and I'm going to show that as 1x. So it's -5 times 1x, which comes out as -5x's. And then here we go. The second term here is -5 times, that's a -1 because of the minus sign. And -5 times -1 is +5 right there. All right. Now we got the rest of this. We got the rest of this equation right there. So let's go and just drop it. Now the reason why I'm doing that is because I don't see any other distribution that is necessary. Which is good, because now I can move straight into combining like terms. So I would like to see that as a -1x right there. So when I combine my x's, which I will do now, how many x's is this going to be? Well, we got -5x's, and then you got -1x's. So -5 minus 1 is -6x's. But then I also have a 5 and a +1. So that just comes out as 5 plus 1, which is 6. Now that's +6, so I'll show that as +6. And then yeah, this is all going to equal still the -18. Okay, so that's all the combining like terms that I can do for now, which means that now I'm looking to use principles of equality to make zeros. So let's go and do that. So first principle of equality, this is just like what we saw in the bell work. It should only take 2 principles of equality to solve this one. We got the +6. I'm going to zero that out by subtracting 6. But if I do it to one side, I got to do it to the other side as well. So that will zero that out. I can now drop this -6x's, which equals now -18 minus 6, which is -24. Last thing I need to do here is to make the coefficient of x a 1. Because I do want this to be 1x, not -6x's. So how do you change a -6 to a 1? Just divide it by itself. Divide by -6. But if you do it to one side, you're going to need to make sure that you do it to the other side as well. And -24 divided by -6 is +4. So this should be my answer right here. But yeah, the last thing we're going to do here is just check. So I'm going to come up here, I'm going to replace this x with 4. And I'm going to replace this x with 4. And then we're going to see if I get a true statement out of my calculator. And I'm typing in exactly like I see. So -5 parentheses, parentheses 4, close parentheses, -1, close parentheses, -4 plus 1. And again, before I push enter, I'm expecting to see -18. Yep, I do. Which tells me that we did this correct, meaning that if you replace the x with 4, you get a true statement. That means we have the solution. So yeah, up there at the top, you can put a question mark right there, because I was just checking for truthfulness with the blue 4s, but I did find that it was true. I know that's one example, but try this one on your own. See if you can do it. Give you guys 1 minute, then we'll go over it together, okay? So first thing I'm going to do on this one, I do see parentheses again, which indicates that we are looking for some form of distribution, which is multiplication. And I would like to see that as 1x. So I'm going to take this 4 groups of 1x. That would give me 4 x's. All right, then I also have 4 groups of -1, which comes out as -4. So it just reads as -4, that's it. Everything else, there was no other distribution necessary here. And do be careful, because some students, especially while we're getting used to this distribution stuff, they tend to distribute to the 4x, but distribution is multiplication, and this shows addition between that term and this term, okay? So you cannot distribute the 4 to the 4x or the -1. But now that we have the distribution out of the way, we are ready to combine any like terms that we have, such as these 4x's and these 4x's. Okay, so that's 4x's plus 4x's, which is 8x's. And then we also have a -4 and a -1 combined, so it's -4 minus 1, which is -5. Now this just equals 19. But at this point, we're now ready to use principles of equality to solve. So that's what I will do. So my first principle of equality is just to use it, is just to make that -5 become 0. I'm going to force it to become 0 by adding 5. But if I do that to one side, I got to do the other side as well. So that will zero that out. I'm going to drop my 8x's. And on the right side, I got 19 plus 5, which is 24. Last thing I need to do here is to make my coefficient of x a 1 instead of an 8. But I do have an 8x, and so to make it a 1, I'm just going to take that 8 and divide it by itself, 8. If I do it to one side, I will do it to the other side as well. So yeah, 8 divided by 8 here is 1. That's how we get the 1x, and then 24 divided by 8 here is 3. So that's what I get. Will that make the original equation true though? So let's go back to the original here at the top, and I'll replace this 1x with 3. And this x here right here with 3 as well. And I'm just checking for truthfulness, right? So I'll come to my equal sign and I'll put a question mark here because I don't know if this is true yet. So I put that in the calculator already while you guys were working, and I got that it was true. I got 19 equals 19, and so it does end up being true. I do hope that you check that on your own though, just to confirm that. But now I know that if you replace the x's with 3's in the original equation, you get a true statement, which tells us that x is 3. If you replace the x with 3, that is the actual solution. Okay, and on this one, well, there's 2 equal signs on this. I don't know if it printed like that. If it did, whether it did or not, let's just make this a minus sign right there. Okay, so we'll keep the equal sign here. Just make that a minus sign. If it printed as minus, then keep it. All right, so we're just going to solve this like this here. And I do see this parentheses, so I'm looking for some distribution, right? And I'm treating this as -3 because the minus sign to its left. And yeah, if you'd like to see that as -1x, then do it. Well, that's -3 groups of -1x, which actually comes out as positive 3x. And I'm showing the positive sign because of the -24 there, which will end up coming out as a plus 3x. But then with the second part of the distribution, I got -3 times -3, which comes out as positive 9. Okay, so everything else stays the same. We got the -24 plus 3x plus 9 plus, I'm going to make that plus 1x plus 3 equals -18. Well, that completes any distribution that we saw when we did, so we distributed. Next up, let's do some combining like terms, and I'll start with a constant just because it's the first term on the left. Got this -24 there, and also we got this positive 9 and positive 3. So I just put that in the calculator as -24 plus 9 plus 3. And when you do that, looks like we get a -12 out of that. Okay, but then I got my x's that I need to combine. So how many x's will that result in? Well, 3x's plus another 1x, and comes out as positive 4x's. So this should all equal the -18 that we had there at the top. But you notice on the left side of the equal sign we had 1, 2, 3, 4, 5 terms, but there were only 2 different types of terms, x terms and constants. So when we combined all our like terms, we ended up with 2 different terms because there was only 2 different types of terms. And now that we have that, we are now ready to use principles of equality to solve this. Okay, so that's right now it's that 4x. I like it there. I just don't want that -12 with it. So I'm gonna have to zero that out by adding 12. And yeah, if I do it to one side, I'm gonna need to do it the other side. So that will zero that out. I can now drop my positive 4x's. It's positive because of the plus sign. And then negative 18 plus 12, that should give us negative 6. Last, I need to make that coefficient of x a 1, about 1x. So how do I make a 4 1? Just divide it by itself. Divided by 4, and we're going to end up with a fractional answer. I think some of you guys would prefer the decimal, but I'm pretty sure we want the fractional answer on this one. So negative 6 divided by 4 is going to end up being negative 3 halves. Okay. Now that should be the solution, but to be sure, let's go up here at the top. Let's replace our x's with negative 3 halves. And just check for truthfulness. So there's a question mark over my equal sign there. All right, so I'm typing this in exactly like I see it, negative 24 minus 3 parentheses negative, and then I'm going to put another parentheses for my fraction, negative 3 halves, and I'm using the n over d button. And then minus 3, close that parentheses, plus parentheses negative 3 halves. And the n over d button is useful here. And then plus 3. And then when I push enter, I'm expecting to see negative 18, and I do. So that confirms that we get a true statement when we replace the x with the fraction negative 3 over 2, which tells us that we have the solution. As long as you replace the x with negative 3 over 2, like we see down here, we end up with a true statement in the original equation. Let's go and do this one together so you guys have some time to do the assignment. But yeah, with the parentheses, that indicates that we do have some distribution that's necessary here. So I will do that distribution. So I'm going to start out with negative 5 groups of 5 x's, which turns out to be negative 25 x's. And then also negative 5 groups of 3, which is negative 15. Okay, so that's all the distribution we have. On the left side, we still got the negative 40 minus 4. And then to the right of that, we still got the minus 3x plus 1. Minus 2x. Now, we've just completed all the distribution that's necessary, but we now need to look to combine any like terms that we have. And there are some like terms, not only on the right, but the left as well. You got negative 40 minus 4, which you can put that in the calculator if you need to, and I would recommend doing that until you get used to this stuff, but get negative 44. And then we'll combine the x's, right? I got negative 25 x's, negative 3 x's, and negative 2 x's. Okay, so how many x's would that be? It appears to be negative 30 x's. And then we also got negative 15 and positive 1, which comes out as negative 14. So this is my new equation. It's the same equation, it's just things aren't broken up like they were in the last line. So now that I have that, I'm going to go to principles of equality to zero out that minus 14. So it's a negative 14 term though, so I'm going to zero it out by adding 14. It's just if I do it to one side, I got to do the other side as well. So negative 44 plus 14, that'd be negative 30. And then my negative 30x, that's the whole idea, is that we could be able to drop it, and then negative 14 plus 14 is 0. Okay, so this is my new equation. And the last thing I want out of this is for the coefficient of x to be 1x, to be a coefficient of 1. So how do I make that a 1? I'll just take the negative 30 and divide it by itself, coefficient. But if I do it to one side, and make sure I do it to the other side, and negative 30 divided by negative 30 is 1. So right here, that's pretty much as far as we need to go on this one. So we're saying here, at the very bottom, if you replace the x with 1, you should get a true statement, right? So let's come back up here. Let's say, so I got this x, let's replace it with 1, this one as well, and this one, okay? And let's check for truthfulness. I've got a question mark over the equal sign. So we already know negative 40 minus 4 is negative 44, but on the right side, it's kind of big, but negative 5 parentheses 5 times 1 plus 3, close parentheses, minus 3 times 1, plus 1, minus 2 times 1. And when I push enter, I get negative 44. So that indicates that it's true. The equation is actually true when I replace the x's with 1s. Now, if you replace the x's with anything but 1 for now, you get a false statement. But we needed something that was going to be true. We just found it, which means that if you replace the x with 1, that's our solution. There's our two objectives again. I believe that's the same exact two objectives that we saw last time. So as long as you can distribute and then combine like terms, use principles of equality, this stuff comes out pretty easy for you. Again, we see that sometimes it's a little bit more work than maybe what we'd want, but it's just work. It's not like it's harder work, just more work.